Okay, we're going over special derivatives answers. So the first question has to do with absolute value. So when we're dealing with f of x is equal to 4x minus absolute value of x squared minus 2x, all divided by 3x plus 1, and we want to find the derivative of this thing, the first thing that you have to do is you have to write it as a piecewise function. And so if we want to find this as a piecewise function, to find your piecewise function, you need to find the pivots by setting the x squared minus the 2x equal to 0. So we're left with x times x minus 2 equals to 0, which means that x is equal to 0 and 2. Now we do this because that's where the graph changes from positive to negative. So if you think about the number line with 0 and 2 on it, you could think about what the graph would look like of x squared minus 2x, which would be something like this, or you could test it in other ways. But regardless, this part here would be positive, this would be negative, and this would be positive. So the graph splits up at 0 and 2. Therefore, what you have for your f of x as a piecewise function is you have 4x, and then where it's positive, all we do is we drop the absolute value, so over 3x plus 1, and that's when x is less than 0 or x is greater than 2. You could put the equal sign on there if you want to as well. The other equation would be what happens when it's negative, and to get rid of the absolute value when it's negative, you times by a -1, so you get positive x squared minus 2x, all divided by 3x plus 1. Oops, don't need that. And that's going to be in between 0 and 2. I put the equal sign on that one. So this is what your f of x is. I might tidy this up. So when you're finding your f of x, the top would be a negative x squared and plus 6x divided by 3x plus 1, and the bottom would be x squared plus 2x divided by 3x plus 1. This is for x is less than 0 or x is greater than 2, and this is for a 0 less than or equal to x less than or equal to 2. Now the disadvantage of now finding your f prime of x is that you have to do it twice. So let's call this case 1, and let's call this one case 2, and we're going to see how this works. For case 1, we're going to use the quotient rule, so the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. And so we're going to get negative 6x squared plus 18x minus 2x plus 6. And then minus minus is going to be plus 3x squared minus positive is going to be minus 18x, all divided by 3x plus 1 squared, which we don't expand. And so that one's going to be a negative 3x squared. Those guys seem to disappear. Minus 2x and plus 6 divided by 3x plus 1 squared. So now for case 2, we're going to find f prime of x. And it's going to be, again, the bottom function, 3x plus 1, times the derivative of the top, which is going to be 2x plus 2, minus your top function, which is x squared plus 2x, times the derivative of the bottom, all divided by the bottom function squared. So that's going to be 6x squared plus 6x plus 2x is 8x plus 2, minus 3x squared and minus 6x, all divided by 3x plus 1 squared. So my f prime of x is equal to, let's see, we're going to end up with 3x squared this time. Those guys are going to cancel off. And we're going to get a positive 2x and a plus 2, all divided by 3x plus 1 squared. So that means that f prime of x is going to be piecewise function. The first one is negative 3x squared minus 2x plus 6 divided by 3x plus 1 squared. And that was for x is less than 0 or x is greater than 2. For the next one, we're getting 3x squared plus 2x plus 2 divided by 3x plus 1 squared. Whoops, plus 1 squared. And that's going to be in between. And we're actually going to take off the inequality values now. You will see why in a little while. But for right now, we don't take the derivative right at those pivots. And that's going to be what the first one looks like as we go through these questions. Now, for part B, it says find the equation of the tangent line when x equals 1. So x equals 1 isn't in both of these, so you only actually figure out where x equals to 1, and that happens in here. X equals 1 only in this one. So we're going to use this formula for the slope of our tangent line. To find the slope of my tangent line, I'm going to plug in 1. I'm going to get 3 plus 2 divided by 3 plus 1 squared. So that's going to be 7 over 16. And I only use this function, which means that I also only use that function to get my y value. To find my y value, I have to go back up to f of x. So I'm going to get 4x minus, if you want, you can just plug it right in from the beginning, 1 minus 2 inside here, divided by 4 times 1 minus 1 minus 2, divided by 3 times 1. So I'm getting 4 minus absolute value of negative 1, which is going to be 1, over 3, so that's going to be 1. So that means that my equation is going to be y minus 1 is equal to 7 over 16 x minus 1 for that guy. Okay, that's absolute value. For the second question, find the derivative of f of x with respect to 2x squared plus x plus 1. So if I want to find the derivative of f of x with respect to g of x, right, what we figured out by the notes is that all you're really doing is you're finding f prime of x divided by g prime of x. That's the simplest way of figuring it out. So what we're doing is we're finding if f of x is equal to 4x squared minus 3 to the power of 1/2. Oh, no, 4x cubed, sorry, my mistake. 4x cubed minus 3 to the power of 1/2. Then f prime of x, using our chain rule, is going to be 1/2 times 4x cubed minus 3 to the negative 1/2 times its chain, which is going to be 12x squared. G of x in this case is equal to 2x squared plus x plus 1. So g prime of x is equal to 4x plus 1. So what my answer is that the derivative of f of x with respect to g of x is equal to 1/2 times 4x cubed minus 3 to the negative 1/2 times 12x squared, all divided by 4x plus 1. And if we simplify that up, the 2 and the 12 are going to cancel, and we're going to get an x squared on top and 4x plus 1 times the square root of 4x cubed minus 3 on the bottom. That's what you're going to get for that guy. So these questions on today's lesson are really just sort of little tiny things, right? They're things that they could show up maybe on a multiple choice question or 2 multiple choice questions or something like that, but they're not major concepts when we're going through this. Okay, the next one is the inverse function question. So when we take a look at the inverse function, we have to remember that if you have something like f of x and you have the point a comma b on it, and g of x is the inverse function, then g of x is going to have b comma a. So if g of x is equal to f inverse of x. So keep that in mind. So it says if f of x is equal to 4x squared minus 3x minus 2, and it has an inverse function, so f inverse of x is equal to g of x, and I don't really want to find it, find g prime of 8. So g prime of 8. What we figured out is that when they're inverses of each other, here's how our derivatives work. G prime of something, let's call it square, is equal to 1 over f prime of something, let's call it triangle, where, that's a prime by the way, triangle and square is on f of x. So what that means is if that you're looking at the point, the x value for your f prime is the x value here, and the g value is here on that guy. So you've got those things going on. So if I'm looking for g prime of 8, it's actually going to equal 1 over f prime of, let's call it a, where, and this is the sentence that I always write to myself, a comma 8 is on f of x. This is the key to doing these inverse questions right here. So the key is that I want to figure out f prime of a. So f prime of a, if I look at this, f prime of x is equal to 8x minus 3. F prime of a will be 8a minus 3. So that's great. But I still need to figure out the value for a, and that's where our equation is going to come in. So if you have f of x is equal to 4x squared minus 3x minus 2, and I want to figure out a comma 8 is on f of x, it means that 8 is here and 4a squared minus 3a minus 2 is here. And we're going to solve for it. 4a squared minus 3a minus 10 multiplies to 40, adds to negative 3. I guess that's 8 and 5. 8 and 5. So what we're going to end up with is we're going to end up with, that doesn't make 8 and 5. Well, that was a bit of a whoops. 8 and 5, much better. Okay, so negative 8 and positive 5. And so I get my a value to be negative 5 over 4 or positive 2. In the question, it says that a, or x anyway, all of our x values have to be less than or equal to 3 over 8. So I can't take that one. It's sort of narrowing it down for me. So by using this guy right up in here, by using this little information, g prime of 8 is now going to equal 1 over f prime of negative 5 over 4. And so what I have to do is I have to find f prime of negative 5 over 4. So f prime of negative 5 over 4 is equal to 8 times negative 5 over 4 minus 3. So those are going to be gone. I'm going to get negative 10 minus 3, which is negative 13. And my answer would be 1 over negative 13, or negative 1 over 13. I'll come back to another one of these in a couple of minutes, but that's the idea behind the inverse function, is that we don't actually have to find the equation of the inverse to be able to deal with it. We use that property that we had. Okay, the next question that I'm taking a look at, it says, I think this is another inverse question. This is question number 4. It's giving that f of 2 is equal to 6. G of 2 is equal to 7. F of 6 is equal to 3. G of 6 is equal to 2. F prime of 2 is equal to negative 4. F prime of 6 is equal to 5. G prime of 2 is equal to 9. Do I need any more? I don't have any more primes? Okay. And the fact that f of g of x is equal to x. So that's a big key for what this question is telling you. This part right here, this is what this means. If you remember from Math 12, we figured out that f of f inverse of something was equal to the something, right? They popped out from each other. So if you say that f of f inverse of x is equal to x, it means that these two functions are inverses of each other, and they're sort of canceling each other off. What this question is saying is that f of g of x is also equal to x, and what that you can conclude from that is that f of x is that g of x is equal to f inverse of x, because they're doing the same sort of thing, right? Whether I write it like this or whether I write it like this, it doesn't really make a difference, but what this is telling us is that these two things are going to be the same. It's another way of showing that the two functions are inverses of each other. So what does the question say? We want to find g prime of 6. And g prime of 6 is going to be 1 over f prime of a, where a comma 6 is on f of x. That's the sentence that you really want to figure out every time you're doing these inverse things. You're trying to find g prime of 6. They're inverses of each other, f and g. So g prime of 6 is going to be 1 over f prime of a, where a comma 6, that's not a b, a comma 6 is on f of x. Okay, so let's look at our f of x's. There they are. A comma 6, it's from right here. What that tells me is that 2 comma 6 is on f of x, which means that our a value is 2. So that means that g prime of 6 is equal to 1 over f prime of 2. And if I just take a look at my table, f prime of 2 is -4, and I've got myself my answer. So that's how we do that inverse question when we don't actually have a function that we're dealing with. Okay, so that's inverse. I might come back to that a little bit in a couple minutes as well. But for right now, we are doing definition of derivative. And I'm going to keep doing these definition of derivative questions so that you can recognize them. They are usually some of the trickiest questions out there. So if you're finding it tricky, you're not alone and not the first. So what we're trying to do is we're trying to find the limit as h approaches 0 of 3 times -1 plus h to the power of 100, that seems like a lot, minus 3 all divided by h. So nobody wants to expand out that -1 plus h to 100. If I plug in 0, you're going to see that it turns out to be 0 minus, it's going to turn out to be, 3 minus 3 over 0, which turns out to be 0 over 0. So it does have to be fixed. So hopefully, because you've got the h's in here, hopefully you can think of it like this. We know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. If I wanted to find the slope of my tangent line, it would be what I get when I plug in a number. So I would end up with the limit as h goes to 0 of f of a plus h minus f of a all divided by h. And the key to recognizing this definition of derivative is that you've got h's in it, you've got something plus h inside your function ideal, and this is what I'm looking for right here. So what we're saying is that f of a plus h is really equivalent to writing 3 times -1 plus h to the power of 100. The h's are the same, which means that if you look inside the brackets, it's telling you that my a value is -1. And so what we're really finding down here is we're really looking for, whatever function we're dealing with, we're looking for f prime of -1, and that's going to give me this slope of the tangent line kind of idea. That's the goal, is f prime of -1. Now we also need to be able to figure out my function. So I use a dummy variable for this. F of something is equal to 3 times, now what's that, once that's -1, 3 times something to the power of 100. Or if you want, f of x is equal to 3 times x to the power of 100. I can find f prime of x. It's 300 x to the 99. And so now, if I wanted to find f prime of -1, it's 300 times -1 to the 99. Now, I wouldn't put -2 in there because that would be terrible. But -1 to the 99 is -1 times 300 is going to give me -300. And as we learn more functions, I'll try to do more of these so that you get comfortable with them. Again, it's a multiple choice type situation. It is not going to be like the end of all the questions, but it's as much as you can recognize that definition of derivative. Okay, last question. Question number 6, we've got a table in front of us, so you guys should have the table in front of you. You've already tried these questions, so they're all done, right? They're all perfect. And we've got 1, 2, 3, 4. I'm just writing them here so I can circle them if I need to. And I've got f and g and f prime and g prime, I believe. Yes. Okay, so the first question says that m of x is equal to the square root of 2x times f of x squared minus 1. And we want to find d dx of m of x, and then x equals to 2. So d dx means the derivative, let me just go the derivative of m of x with respect to x when x equals to 2. So that's what that's going to be looking at. Essentially, it means find m prime of 2. So this means find m prime of 2. It's just a fancier way of doing it. So before I'm going to find m prime of 2, I'm going to rewrite this as powers. So I've got 2x to the power of 1/2 times f of x squared minus 1. And this is all about chain rule and product rule. So to find m prime of x, I'm going to take the derivative of my first guy. I'm going to do this in colors, I think. The first guy is going to be red. So I'm going to get 1/2 times 2x to the power of negative 1/2 times the chain, while the second buddy waits. So the second buddy is doing nothing. And then what I'm going to do is a plus sign. That first buddy is going to wait, 2x to the power of 1/2, while I take the derivative of the second buddy, which has 2 layers. So that second buddy is going to be f prime, which is the outside layer, while the inside doesn't change, and we chain it up to the derivative of the inside, which is 2x. Now what I'm going to do is I'm going to find what happens when it's 2. So to simplify this, what I'm going to do first is I'm going to, those 2's cancel off. This really means that you've got, I'm going to do one more line here. This really means that you've got f of x squared minus 1 over the square root of 2x. And over here, you've got the square root of 2x times f prime of x squared minus 1 times 2x, and you can put that 2x anywhere you want. So now we want f prime, or m prime of 2. So we're going to get f of 2 squared minus 1 over the square root of 4 plus the square root of 4 times f prime of 3 times 2x, which is 2 times 2, which is going to be 4. So looking at my table, f of 3 is right here. It's negative 4. So I'm going to get negative 4 divided by 2 plus 2 times f prime of 3. F prime of 3 is going to be 5. So 2 times 5 times 4, which is negative 2 plus 40, which turns out to be 38. So that's your first one. Nothing new there, it's just extra practice. The second one says find the equation of the tangent line. So I think I can probably still look at this. If I want to find the equation of the tangent line, I need a point first and I need a slope. To find my point, my y value, when x is equal to 1, my y value is going to be g of 2 times x, which is g of 2. And g of 2, oh, gotta look at my table here, g of 2 is equal to negative 6. So that means that my point is going to be at 1 and negative 6. To find my derivative, if y is equal to g of 2x, my derivative, y prime, slope of the tangent line, is g prime of 2x, and then times 2, or 2 in front if you want. So y prime is going to be 2g prime of 2x. When x is equal to 1, the slope of my tangent line is going to be 2g prime of 2, which is going to be 2 times g prime of 2, which is 3. So that's going to equal 6. So the equation of my tangent line is y plus 6. That's y minus my y value is equal to my slope times x minus my x value. And there we've got that. Okay, now we're on to 3, or part C. Part C and part D are both inverse questions. So it says h of x, some function h of x, is equal to g inverse of x. We don't know anything about h of x, but we do know we're trying to find h prime of 4. So h prime of 4 will be 1 over g prime of a, where a comma 4 is on g of x. It's whatever this function is down here that we're looking for that point. So we're looking for some place where my g function has a y value of 4. And if you take a look at your g function, I think if you go back to here, my g function had 6, negative 6, 4, and negative 3. So we are looking for this guy right here. The g value is 4. Okay, so that means that my a value is going to be 3. So it's 3 comma 4 is on g of x. Okay, so we're going to get 1 over g prime of 3. Now we look at our table for g prime of 3, and if we're taking a look at g prime of 3 over here, g prime of 3 looks to me to be negative 10. And so we're going to get 1 over negative 10, or negative 1/10, as my answer. So these inverse questions are really always going to be the same as we go through here. Okay, so now we take a look at D. And when we take a look at D, it's the same question, right? We're going to go z of x is equal to f inverse of x. I just figured we'd do a different practice question, exactly the same. Z prime of 2 is going to be 1 over f prime of a, where a comma 2 is on z of x. So again, we're going to look at our table, and what we're looking for is we're looking for a y value of 2 on my f function this time. So when I go back up to the table and I'm looking at my f function, it's 2 and -5 and 4 and 1, and only one of them has a y value of 2. If there was more than one, you'd list them all. So my f value, the y value is 2 when a was 1. So 1 comma 2 is on this. Okay, I'm going to go back here and just ignore that z of x. Take a note that it's actually on f of x. If that was confusing, my apologies. That f of x right there has to match this guy. That's why I'm looking for the 2 on my f of x function. And this is the a value. This is the 1 on my f function. Sorry for the confusion. Good thing I caught it right there. But that's what I'm looking for. So what I'm going to get for my answer is 1 over f prime of 1. And so for me to find f prime of 1, I'm going to go look at my table, and my table seems to have a -4 sitting on there. So if I have a -4 sitting on there, I'm going to get my answer of -1/4. So hopefully that works out. And finally, we're going to go into the last question, which is just like review, and we're going to take a look at question E, where we're going to be solving g of 2x equals to 0 using Newton's method. Okay, so the most confusing part about this is that it's g of 2x, not g of x. So sometimes what might be useful is that just saying h of x is equal to g of 2x. And what we're going to do is we're going to solve h of x equals to 0 using Newton. Okay, so if h of x is equal to 0, what we have to do is we have to figure out h of x, and we also have to figure out h prime of x, which is going to be g prime of 2x times the chain, which is going to be 2. So the first thing we're going to do is we're going to find x1. Our x naught value for this function right here is given to us to be 1. So that means I have to go 1 minus h of 1 divided by h prime of 1. So when I take a look at h of 1, it's going to be g of 2. And again, we look at our table for g of 2. And if I take a look at my table for g of 2, it's going to be -6. H prime of 1 is going to be 2g prime of 2, which is going to be 2 times g prime of 2, which is 3, which is also going to be a 6. So I'm going to get 1 minus -6 over 6, which is 1 plus 1, which is 2. Now it says find x2. So it's going to be 2 minus h of 2 divided by h prime of 2. So 2 minus, let's go over here. H of 2 is going to be g of 2 times 2, which is 4. And h prime of 2 is going to be 2g prime of 2 times 2, which is 2 times g prime of 4. G of 4, if I take a look at my table correctly, is -3. And g prime of 4 looks like 12, so 2 times 12 is going to be 24. So I'm going to get 2 minus -3 over 24, which is going to be 2 plus 1 over 8. 8 times 2 is 16 plus 1 is going to be 17 over 8. And so for us, our x2 value is going to be 17 over 8. So I hope this helped a little bit. And keep practicing with these special derivatives. But again, these are like one-offs, usually on multiple choice or something like that, where they're asking, or even like one part of a written question, they're asking something. Keep practicing and figure out as much as you possibly can, and hopefully it goes okay.